Assalamu alaikum wa rahmatullahi wa barakatuh. I'm here with my friend Mohammad Hassan. I've just met him. Originally from Pakistan, right?
From Pakistan.
Okay, and so you're involved in RISC-V, and you did tell me before that you are a PhD student. So maybe it's better for you to introduce yourself and tell us a little about your background, how you got involved in RISC-V, just anything you feel comfortable sharing.
Okay. So my name is Mohammad Hassan, and I'm originally from Pakistan, but I have been in Germany for quite a while now. So I did my bachelor's from Pakistan in telecom engineering from FAST University, and then I came to Germany to do my master's in communication engineering from RWTH Aachen, or in German they call it RWTH Aachen, and then I went to do my PhD from University of Bremen. And my PhD is in the direction of verification of heterogeneous systems. And when you talk about heterogeneous systems, of course, RISC-V plays an important role because that's the processor which is driving the digital side. And currently I'm working as a senior researcher and a postdoc at University of Bremen and German Research Center for Artificial Intelligence. And because now we are talking about, I'm introducing myself, so I also have a startup, my own, but it is working in the direction of blockchain security.
Oh, that's interesting.
Yes.
Okay. Because my background's in the financial sector, and I've looked into Bitcoin and blockchain and different.
Okay.
Yeah, different stuff like that. So
that we can talk about it later on. But currently, because we are at the
definitely it's something interesting, and it's something that we can also link to RISC-V. Using accelerators and FPGAs.
Of course. No, but like I mentioned, like my PhD is in the direction of heterogeneous systems verification. So that's where, and from my research group, which is the Computer Architecture Research Group from University of Bremen, we primarily focus on the verification and testing of these heterogeneous systems, like starting from the system level to the gate level, transistor level, and beyond.
So let's just go back a few steps. I mean, when you was back in Pakistan, did you know anything about RISC-V at all? Did they mention it at the university?
So at that time, RISC-V was not introduced.
Okay.
Because that was back in 2010 I graduated.
Okay.
So at that time there was no idea of RISC-V. I knew about the RISC architecture, because that's very of course. But not about RISC-V. But I got to know recently that in Pakistan also a lot of universities are now, in the last 3-4 years, they have been trying to catch up. Let's call it that. And now there have been there are different startups and companies which are working in this direction. Universities are also noticing this, and also they are changing their curriculum, which is more focused towards RISC-V. So that's a good thing. And the best part is, and I was just telling it yesterday to some of the students here, who are also from Pakistan, that the advantage that RISC-V gives you is it's open source. So you can contribute to it from anywhere in the world. So it's not limited only to Europe or to US or to Australia. Even if you are in Pakistan or in India or in South Asia or any country in the world, you can contribute to it. All you need is an internet connection, and I assume everybody has a cell phone nowadays.
So basically, it's a bit like open source software in a sense open standard.
Yes.
So you can basically just implement the standard and they extend it through this something called extensions. So you can create your own extension and pretty much create your own processor. So it really opens the market for everybody.
Exactly.
Before it was very closed. It was like a monopoly between oligopoly. They call this a couple of players. Like your AMD and Intel, and they've got the complex instruction sets, which is and they've got the proprietary, and you have to pay a license, and they'll even give you all the details of exactly how they've designed things. But with this, it's all transparent.
Yes.
And that's the thing that actually interested me personally, is that if there's any sort of vulnerability in the hardware side, you got Spectre, Meltdown, and they mentioned Cherry in some of these talks. Anyone could just go in there and say, "Oh, I've got a solution. I know how to fix this," and they can implement their own fix and create their own solve the problem.
But so there's one slight difference. So RISC-V is open standard. So that means the standard is open. Anybody can take it and implement it. but your implementations, so this actual implementation of the processor, it might not be open source.
Okay.
So it is quite possible that, for example, you take the standard, you implement the processor code, and you
close it.
You ship it to the customers, and you don't show the code to anybody.
Okay.
Now, one of your customers says, "Hey, we have a bug in the system," and now because it's your proprietary property, so and you have not made it open source, people cannot look at the implementation and say, "Okay, this is the actual exact location where the bug is."
Yeah.
So that's the difference.
So they can do that only if you make it open, like open hardware.
Like
I think
open
open hardware, you got the
exactly.
GitHub and you can download. And I mean, I haven't tried it, but what exactly are we downloading? A Verilog code that we just do it on an FPGA chip.
Yeah, exactly.
So yeah, I haven't done that yet. All I've done so far. When I got started, we just emulate the architecture using QEMU.
Oh, okay.
So it's a bit like, the people that know where it's like a bit like VirtualBox. You virtualize your another operating system, but you can virtualize also the hardware. So you choose the hardware, and so that's what I've done, and I compiled just some basic C code and that kind of stuff. I personally didn't find maybe I didn't look hard enough, but I didn't find a structured module in the UK. So I'm actually impressed that Pakistan is starting to do that, because I know universities. I know some universities that were here, represented here, but in the summit. But there are some universities in the UK they're not aware of RISC-V at all, and they're not teaching anything. It's like completely black box.
It's quite possible, but it might also be that they're using RISC-V in a different context. For example, they might be teaching computer architecture course, which is driven by RISC-V, or they are using RISC-V as a case study during the teaching process.
Okay, yeah.
So they might not name it like computer architecture with RISC-V focus or something like this. Rather, they would just say, "Okay, we are teaching a computer architecture course," and in the contents, when students go into the class, they see, "Oh, okay, it's about RISC-V."
Yeah,
it's quite possible. So they're not maybe marketing it in a way. They should, of course.
Yeah, I mean, I did a couple of computer science degrees, master degrees, and they did cover architecture, but it wasn't like maybe in depth as someone that's doing electrical and electronic engineering.
Oh, okay.
So it was kind of maybe a more high level, binary and two's complement, all that stuff, and just basic stuff. But they didn't go into the different architectures and the RISC, and they didn't do that. They just said, okay, these are processes. So it's kind of like in there, but maybe it's because the master programs that I was on were more towards software. They were like software engineer, so you covered more programming, database, that kind of stuff. And then there was artificial intelligence. I did like advanced computer science course, or data science course, and it was all to do with data, handling big data, that kind of stuff. So they were not going lower level, and now I'm trying to go, from the high level of Java and
so complete all the abstractions.
I'm trying to go right down and try to understand exactly how everything works down to the bits. And that's what's interesting me.
Do you plan to go more towards photonics and how electronics?
No, not that. At least I get to the level where I can understand Verilog. I know it's similar to C, right? Verilog. It's very similar. So I know C. But I've got more experience in Java and C#. I've done C# as well, I've done C++, but I've got more years experience, commercial experience in Java field than C. So, but I know the syntax are all the same. So that does interest me, and also it interests me because I don't want to mention any financial institutions that I've worked for on the recording, but there was one major financial institution in the States, and they were basically switching from software calculation, like risk calculation, that kind of stuff, from software using this quant-lib library from C++ to hardware, to like basically doing all the calculations on FPGA chip.
Because it's much faster.
Much faster, yeah. And I did some training on writing code, but I had to write the code in Java. And then this was many years ago, and it would just basically convert it down to Verilog, and then it would go. So it wasn't like I had to learn how to, use that. It was like use the IDE, which is Eclipse, and you can, you just generate the code, and then that's what's going to be burnt on the chip, basically. So, yeah.
And because you mentioned about like if universities are teaching the course at least, so from Germany, I know at least for example in University of Bremen, our research group or the courses offered by our research group, they include RISC-V. So we are very heavily focused on RISC-V. For example, I'm teaching the course Computer Architecture and Embedded Systems.
Right. Can I join it?
Yeah, of course.
In Germany.
It's in Germany. You have to come to the University of Bremen.
Okay, that means I have to enroll for your university as well.
Yeah, of course. You can also attend the class without enrolling. And
really?
I think so. I don't know. You have to talk to the university administration.
Okay.
Yeah, but then so we are also like teach computer architecture, but we don't now use the MIPS architecture or any other architecture. We use RISC-V. Like what is RISC-V and how its ISA is like structured, how can one extend the instructions, everything. So, and we in the lecture we teach students like how to use this RISC-V to build their own applications. And now we have another course which is digital design using RTL, and then we help the students to build the complete implementation.
What is RTL for someone that doesn't know what RTL is?
So RTL is the register transfer level abstraction. So it's an abstraction where you can define the behavior of your hardware.
Okay.
And then you can give it the tool. It translates it or synthesizes it into gates like logic gates, and then further into the transistors, and it maps onto the FPGA, or you can also have an ASIC like application specific. Integrated circuit or the ICs, in short, the ICs.
From what I understand, ASIC, that means that basically it's fixed. You can't change the chip after that. But as FPGA, you can do the thing, run it, and then it just runs the architecture, and then you can change it. Because every time it loads, it's got like this like some memory, and it stores it in there. And then once you start up, it loads up again.
Exactly.
And so I know a little bit. I'm still a beginner, but I've kind of played around. But what would be advice for an absolute beginner? I mean, someone, as basically, okay, I've got a little bit of experience. I dabbled with it a little bit. But someone that's, this looks really interesting, I want to know more about it. Where do I start? Maybe it's a computer science graduate, maybe it was someone that learned, as a programmer, self-taught or something, and they now want to understand this, how can I make use of this revolution, Should they go to university and join your course in Germany?
Of course,
anywhere in the world, or join another university?
You can, of course, join our course. That would be really.
Now you have a long queue outside your university tomorrow, so be careful.
You can also
they should go to university and do a course for the best way to them.
You can start with the RISC-V website, RISC-V Foundation website. They have very good resources of if you are starting as a beginner, on which websites further you go. You can also find tutorials on YouTube. So because it's a growing ecosystem and it's a very interesting ecosystem, so people are really contributing to it. And you can then find on the internet, I would say, start from the RISC-V Foundation website.
Okay.
Of course, you can always go to the university. The difference would be the university will have a very structured course.
Yeah.
But online you might not find that. I did see some courses from University of California, Berkeley.
Yeah.
Because they also have this computer architecture course focused on RISC-V. Yeah. And it's really nice. Please check that. If you are coming absolute beginner.
Is that something that they offer like open?
Yeah, of course. It's like their open education initiative. Like in there are multiple universities connected to this. They have these video lectures. They have the PDFs for the lectures or the lecture slides. Yeah. They also have, I think, exercise sheets if you are interested. But you can look at the website of University of California, Berkeley. Search for computer architecture RISC-V. Yeah, and you'll come across this complete lecture, notes and everything. Yeah. Same for Stanford. I think that Stanford also has one. But you can search for any university in the US or I don't know about UK, so I cannot talk about that.
Yeah, University of Edinburgh, I've seen something. Okay. York as well, I've seen there was something to do with computer architecture, and they follow this book. I can't remember. I think it's called Computer Organization.
And exactly, by David Patterson.
Yeah, that's the book. Yeah, and they follow it. They say chapter 1, and they go through it.
That's a really nice book. So you can also so all the universities which are teaching RISC-V at the moment, or computer architecture with focus on RISC-V, they are using that book as a reference.
Yeah.
And definitely that's also something that you can look into. But I would say, because the book is very detailed, start with the lectures and use the book in addition to that. Because then with the lecture you get some focused stuff. Like in the book you will have to read a lot of things. But in the lectures, of course, the instructors also use these slides with some really cool animations, which makes things easier to like follow and understand. So you can do that, and then in addition, when you need to read more, like for further reading, go to that book.
Yeah,
at least that's what I'm saying.
Yeah, and also I did come across Linux Foundation. They've launched a certification. Now I don't know much about it. I haven't gone on. I also don't know if it's. I know did meet someone that actually did the exam, but he didn't. I think he did it before they launched this certification course. So this now there's a course.
Yeah, exactly.
He just sat an exam and exactly he passed and that's it.
Okay.
He got certified.
Interesting. Yeah, because in the keynote, Calista also mentioned, like the CEO of RISC-V International, she also mentioned that they are like trying to. So they already have a course. They are also now motivating more people to join the course and get familiar with RISC-V in a more structured and thorough way, so that they can help the community. So it's all about, at the end of the day, growing or building the community.
Yeah, that sounds really interesting. So how do you see things? I mean, do you go to Pakistan? Just on a side note, do you go to Pakistan? Did you go recently to Pakistan?
It's been 2 years now.
Yeah? Oh, so you don't know how things are going on in the sense of like RISC-V or companies?
No, not in that perspective, no. I always go there to meet my parents and my friends and family.
Yeah.
But I don't go there for like, for...
Do you have like, is there like meetup groups and stuff like that?
I really don't know. Maybe somebody else who's currently living in Pakistan, they can tell you better about that. But I do know that there's this company 10x Engineers. So 10x Engineers. Okay. They are doing really good work. So maybe check their website, and I know, I think he's the co-founder, Bilal Zafar. So I have talked to him. I have talked to him on LinkedIn a few times. Really nice person from the message.
Yeah, it's good. It's good to connect with people.
Yeah, like and then maybe you can connect with him. Yeah, and he can tell you much more about what is or how is RISC-V evolving in Pakistan.
Yeah, I mean, I only can compare the UK and Europe because I worked in different European countries, and what I found in East Europe in particular, they're very active. They have so many events going on, from JavaScript meetup groups to C++ to all sorts of technical groups, on Eventbrite and Meetup. And I used to just every day after work, I just go to one of them, just walk in, just it's a free ticket, and you just go in and you just listen in, and most of it is in English. Most of it is in English, so that was good as well.
These meetups are really helpful. So,
and you network, you meet other like-minded people, other developers.
Yeah, exactly. So of course, what I'll say now, it will be a little bit of divergence. Yeah. But for example, we are currently in my startup, we are thinking like, because we cannot find many people in the blockchain side, especially in blockchain security in Bremen. So we are thinking about starting a meetup, like a monthly meetup or something, so that people, like-minded people who might not be familiar with our company or might not be familiar what's happening in Bremen around blockchain, so they can join in and share what they have. So at the end, it's like, again, like I'll say, developing or building and growing the community of the like-minded people.
Yeah, there was actually a few years back. I mean, just after Ethereum launched, there was a huge demand for blockchain developers and people to build using Solidity. Is it not correct? Solidity, it's something like JavaScript. So they had also like a meetup, and they said free introduction into blockchain development. So I attended that, and after that they give another day. I think it's 2 days, and it says advanced blockchain. But the people behind it, they're teaching you the basics of blockchain. They're teaching you how to develop using Solidity, and showing you the vulnerabilities as well. Like if you make a mistake, it could be a disaster, like the DAO system. So they tell you about all these vulnerabilities, But the whole idea was not just to just give you free training. They want to recruit you
Of course.
Yeah, so they kind of filter out. Okay, so you're a computer science graduate. You've got all the, you work this. So they find out as part of the registration.
Yeah.
They find a little bit about you, how much you know about blockchain, that kind of stuff, and then they give you the training, and then they say, actually, we have a company. And afterwards, they do the pitch.
Yes.
And then it's up to you.
Yeah.
But that way, they've got a lot of people to work for them, as well as I think they're like a consultancy company, so they would train you up, and then what happens? They then place you at clients.
Okay.
They know people that are working in that field, and they'll place you.
Okay.
So they would hire you as an employee, and then.
Yeah, but that's a nice.
But I got free training.
Yeah, but that's
I can't remember most of it now because if you don't practice, you start to forget, and that's the thing. Yeah, so this has been really a pleasure speaking to you. I mean, if there's anything else you want to add, that I can.
No, I think we have added pretty much everything.
A lot.
But it's
standing here, RISC-V Summit.
Summit, of course.
Yeah.
No, but it was really nice of you to because I personally normally don't randomly interact, but you started the discussion, and it's really nice meeting you at the RISC-V Summit, and I hope that we meet each other.
Something, Mohammed. We need to encourage more people, especially people from Asian subcontinent, Pakistan, the Middle East. We need to encourage all these people from ethnic minorities as well to get involved in these movements. Because this is just the beginning of a massive trend.
Yes.
I mean, this is gonna take the world by storm. This is like you being at the start of, say, Bitcoin. You know about Bitcoin before anybody else.
Yeah.
That's what it is. It's a complete revolution. It's about to start. RISC-V revolution, and people need to get involved.
Yes.
Not just in developed countries and first world countries. Which is we've got lots of initiatives in China. We heard in the US, in India, and now you're talking about Pakistan is getting involved. I've seen a lot of Pakistani brothers here. MashaAllah, that's fantastic. But we need. What about the rest of the world? What about Africa? What about the Middle East? What about all these people need to get involved as well, and they need to start, from the education, from the school, and encourage students to look into this. Even as software engineers, I understand electrical. They might teach you all these things, gates. I mean, I did learn that the gate stuff, OR and NOR and all that stuff, XOR. But they don't go deep as someone that's doing electronic engineering. Mm-hmm. So I think they should also introduce it into the computer science modules. Even if you're going to be a software engineer, you need to still understand exactly what goes on under the hood. So how is memory managed? Not just leave it.
Because you mentioned, so currently my department is of computer science. So I am from the computer science department. Of course, I have the background, like my bachelor's and master's in electrical engineering with focus on communication systems. But my PhD is in computer science. And the way we are teaching to the students is all from the perspective of a software or computer science student, how to teach them the computer architecture. So it's a different focus, different perspective, because with the computer science students, like you said, they have some background about the gates, but they really don't know how the other stuff is working. So that's where then we try to add value by teaching the students these courses. But so students need to be from the computer science, electrical. They need to look into RISC-V.
They don't need to. At least they need to look. They have to. It's a must. Well, thank you very much for your time. I really appreciate it.
Thank you very much for having me.
You're welcome. Okay, take care.